review a little bit here. When we are converting from standard notation to scientific notation, the first thing we need to do is figure out where our decimal's at. Before we even start to figure out where we're going to move it, we have to figure out where it's at. So in this number here, 450,000, where's my decimal? At the very end, right here?
Yeah.
Yes, that's where my decimal's at. But where do we want it to be? Between the 4 and the 5. That way our leading number will be 4.5. Is that in between 1 and 10? Yes, it is. That is what we want. Now we got to figure out what our power of 10 is going to be. How can we figure that out? Count the little jumps from the decimal to where it's supposed to be. So we got 1, 2, 3, 4, 5 spaces. Is my power here going to be positive 5 or negative 5? Positive 5. How do we know? What type of number is 450,000? Is that large or small? Large, right? Large numbers. It's all right, guys. Large numbers give us positive exponents. Just like that. We count the number of little bubbles from space to space to space. That gives us our power of 5. 5 spaces. All right. What if we have something like number 5 down here? 721. Is that large or small? Small?
No, large.
It may be smaller than 450,000, but it's large because it doesn't start with a 0. Anytime we start with a whole number, it's going to be a large number, right? See, number 7 starts with a 0. That's going to be a small number. We'll get to that. So 721, our decimal, again, is on the far right. But where do we want it to end up? In between the 2 and the 1 or in between the 7 and the 2? In between the 7 and the 2, right? If our decimal's right there, our one number to the left of the decimal is 7. So is my leading number just going to be 7.2? No, what's it going to be? 7.21. Great job, exactly. We cannot drop any of these numbers off. We have to keep them all there. Unless it's a 0, then we can forget about the zeros. So we'll count. We go over 1, 2 spaces, 10 to the second power. Two spaces tells us what our power is going to be. Right? 85, like I said, it looks like a smaller number in comparison to things like 6 million, but 85 is also a large number. Anything greater than 1 is a large number. Decimals on the end. We want it in between the 8 and the 5. That's only 1 space. 8.5 times 10 to the first. Question? No? Okay. Stay with me, guys. I know we probably all have this down, but we still got to talk about it. Those are our large numbers. They're all going to have positive exponents. Those first 6 are all large numbers with positive exponents. So let's take a look at the flip side. Let's see some small numbers. All these numbers on the bottom start with a 0, so we know that our exponents are going to be small, but also negative. Negative exponents. Right? We don't need to identify where our decimal's at because we can see it. So where do we want this decimal to end up now? On the far right? Are we sure at the end?
No, in between the 8s.
In between the 8s. If we move it all the way to the end, now we have 2 numbers to the left. We only want 1, right? So my leading number will be 8.8. We get it right in between those 2. Okay? And then we count our spaces. 1, 2 spaces over. 8.8 times 10 to the power of 2. Yes? Does that look right?
No.
No, what's wrong, Daisy?
The negative side.
That's right, our exponent needs to be negative because we have a small number. Yeah. Exactly. Any number that starts with a 0 point is a small number. That'll give us a negative exponent. Exactly. Great observation. Okay, let's face forward, please. Thank you. All right, another small number. Here's our 0 point, right? Thank you. Where do we want this decimal to end up? In between what and what?
9 and 5.
In between 9 and 5, exactly. We get it right in there. We're going to have 9.58 as our leading number. And we're going to move that decimal 1, 2, 3, 4, 5, 6 spaces, 10 to the negative 6th power. We got to be super careful when we have all these zeros because it's easy to count it twice or to skip a 0. You want to make sure you're going right in between each of those little numbers there. 9.58 times 10 to the negative 6th. Okay. Now, if you're having trouble figuring out where am I supposed to put my decimal, I thought it was supposed to go in between the 5 and the 8. Here's a little, a different way to look at it. Take any number that is not 0. So in number 9, we've got 36. We'll rewrite it out. Where does the decimal need to go in this number for it to be in between 1 and 10? Right there, in between the 3 and the 6, right?
Yeah.
That's how we know, boom, that's where I'm going to draw my little arrow, in between the 3 and the 6. Not sure if that helps, but it's a different way to think about it. Take this decimal and move it. 1, 2, 3, 4, 5, 6, 7 spaces. 7 spaces. 3.6 times 10 to the 7. What's wrong? What did I do wrong? That's right. Bless you. Go ahead. I forgot my negative. It's really easy to forget that. Make sure you are paying extra special attention to the sign of your power. All right? And number 10, this is where that little trick might come in handy. I'm going to write all my non-zero numbers. And where do I want my decimal to go? Right here? No? In between the 6 and 2 right here?
Yeah.
Okay, good. That's where we want it to be. That's only one space. So our power of 10 is going to be negative 1. Starts with a 0, negative exponent. If it starts with a 0, negative exponent. All right? Real quickly, just so you can check your answers, 1.9 times 10 to the negative 3 and 9.2 times 10 to the negative 4. Does that look right?
Yeah.
Give me a thumbs up. You got 11 and 12. Yours look like that. Good. Okay, cool. And I got it right. I trust you guys. All right. Even if you turned it in on Friday, go ahead and turn this bad boy back in because I got to go through and